External design features if you're going to build a passive house. Firstly, you've got to look at the site. So it's position and orientation. So if you look at passive house designs, you'll find that you won't get buildings shading each other. You will tend to orientate your buildings north-south. You go back to Georgian times, before electric light. You look at the big grand houses. They're all east-west, big windows at the front. They had fabulous light because they had to. Otherwise, they're burning zillions of candles. And we're sort of going back a little bit to that sort of thinking about orientation on site more, rather than modern developers have got used to just saying, oh, we'll put some roads in there and we'll just scatter the houses around. Pat Borer, who's the guy at CAT, architect at CAT for the last 30 odd years, he talks about plonked buildings, which I think is a lovely phrase, you know, stick it there.
Cookie cutters.
So cookie cutters, yeah. Or a nice big garden and you stick a house right in the middle and you've got all this, you've ruined your garden, you know. So that is really crucial. Optimising the form of the building, form factor, the shape, the external area related to the floor area. So if you build a long, thin building with lots of surface area, it's going to lose a lot more heat than a smaller, compact building with the same floor area. So a quick calculation of measuring the area of roof, walls and floor and dividing it by the floor, by the usable floor area. If it's below 3.5, you're fine, or you're okay. If you're above 4, you're going to struggle. You can get there, but you're going to have really thick walls. Glazing designed to maximise solar gain but minimise overheating. It tends to mean more glazing on the south and less to the north, less to the east and west. But it doesn't stop you doing that. It just sort of, you know, the more you put a bit to the south, you know, predominantly glazed on the south, the easier it is. But one of the exercises they gave us in the CEF course was design this house, and by the way, there are views to the north, so you had to build in windows in the north. Construction types, anything you want to do. It doesn't care about materials. It's not a sustainability standard. You can build it out of whatever you like. You've just got to meet the standards. So if you're building out a masonry, a 500 wall with a 300 cavity generally gets you there. Not a 100 cavity with 50 mm insulation, a 300 cavity with 300 full fill. Build it out of timber. Similar. Stone, yeah, if you want it. I've got a guy doing one self-build. He's building it himself physically with very little help up in Snowdonia. It's got 700 walls with 200 granite on the outside and block. Yeah. There's a cavity. There's a conventional cavity with full fill fibre, 100 mm. There's Embydale, 300 mm. Basalt wall ties, so there's no steel. No heat loss through those compared with the steel wall ties that go in there, which have quite high heat loss. U value 0.28, U value 0.11. U values are the insulation level of them. So lots of, you can use different forms of structure. Masonry, external information, lightweight wooden I-beams, which is what we build in. Massive block plank wall, CLT, very expensive. Not sure about that. Prefabricated lightweight concrete, insulated concrete formwork. You know, the sort of Lego bricks that you pour concrete into. Not very sustainable from a cement point of view. SIPT panels. High-tech vacuum insulation. Look at how thin that is. It's great. It's 70 quid a metre. You know, you can build it out with anything you like. Build it out of straw, you know. One thing I really want to do is build a straw passive house. Nobody's done it yet to my knowledge.
I was going to say, can it be done?
Yeah.
Depends on how you measure the...
I've just got to lean on Barbara Jones a bit harder, because I do all her energy work. It was Amazon Nails, and I've just got to lean on her a bit harder, because she's more into, you know, the cuddly sustainability side of it. Sorry, that's rude. The, you know, materials and really natural materials, which is very important, and less concerned with Passivehaus because it's sort of restricting a bit, but we'll get there. Air tightness is really crucial. You've got to get this air losses under control. It's not difficult. You've done it, Martin, haven't you? I mean, you've not really found it a problem now.
No.
Yeah.
No, at all.
Benefits the occupants. A lot of passive houses in Germany experience 20 degrees. A lot of them, the heating comes on when it gets to sort of 15 below.
Experience 20 degrees. Does that
20 degrees, sorry, 20 degrees below zero,
okay.
outside.
Yeah.
We designed to 20 degrees inside. So you're talking about a delta T of 40 degrees difference. the heat losses are so low that quite often the heating is only coming on at that sort of minus 10, minus 15, minus 20 point, which if you think over here, we don't often experience. One story I heard was they lost the power in a building for 3 days and the internal temperature only dropped from 20 to 17.
It was school, wasn't it?
Was it? Yeah. So, you know, if something, that because you've controlled these losses, you haven't got a problem, and it heats up very quickly too, unless you've got a lot of masonry inside. So you can build with what you like. You know, this has a sun space which gets quite a lot of, because you've got to get that winter solar gain. What you're looking for is winter solar gain when the sun is low to help heat your house, but shading, you know, the big overhangs, to keep it out in the summer to prevent overheating.
Does it recognise things like planting and things around the building? For instance, deciduous trees, summer, winter conditions?
Yeah, you can build that in.
You can.
The amount of data that has to go in is frightening, believe you me. There are 2 sheets for Windows alone, 2 spreadsheets, and they are full of holes, full of things I have to fill in. High surface temperatures. So what you end up with is a temperature, an even temperature house, so it's roughly 20 degrees all over. And you don't have cold areas, you don't have cold internal temperatures. Triple glazing means that you can keep those internal planes at 17 degrees. Because if you get about a 3-4 degree difference, you feel it. Yeah? Like you feel the sun radiating in, you feel the cold. And that helps. You don't get drafts, because you don't get cold surfaces for drafts to drop off. Better air quality. People find that the one thing that people in Denby Dale say is, oh, it's just so nice it feels nice. And people have found, I think people with asthma and respiratory problems, because you're filtering the air, and this was, I think, in Wales, I think this was taken out in a house in Wales, or somewhere in the country, and it's still pretty filthy. You're taking out some of the crap. And in a city, possibly if you've got roads, particulates from diesels, you're going to have better air quality. So I think in terms of the 2 issues for you for roads, for noise and pollution, Passivhaus will help you deal with that, because you don't have to have the windows open for the ventilation. You can if you want, but if it's noisy, you've got triple glazing and you've got better air quality. You've dealt with those 2 problems.
Would it affect which side you draw the air from on buildings and that type of thing? Does that affect noise and pollution and that side of things?
I would think if you've got a massive pollution source on one side, you tend to put your intakes on the other, but other than that, I don't think it matters. The only thing you have to worry about with the ventilation systems is that your intake and exhaust are on the same surface, the same side, because these are balanced systems and they need the same pressure environment. You put one on. You should get good light levels, because you've designed this to be facing the sun, with biggish windows facing the sun, but not to get too hot, so you should have good light levels. So again, that should help you cut down. This is, again, it's German, but it was a cost comparison of running it. I don't know what this glitch is. This is something to do with the way they finance it. But essentially, if you build a conventional house and you build a passive house, you will have a slightly higher cost of build, but your running costs are lower. So for the first 20 years while you're paying your mortgage off, here they are, very similar costs. Once the mortgage is paid off and you're left with the residual running costs, the house is no longer, the fabric's costing you nothing, it's the heating, and that's when all of a sudden, after 20 years, you're dealing with a fraction of the cost of a conventional house because you're not paying to heat it. That is the BRE Innovation Park in Watford, which some of you may know. That's Kingspan's Lighthouse, the first Code 6 attempt. That was interesting. Good try, you know, but there's 1 or 2 things wrong with that site. That's the site. These are the buildings. This is south. They've just built them all in front. This has got solar panels on here, behind this house. Okay, it's a demonstration site. But that's bad design from a Passivehaus point of view. They ran a competition last year. That was the plot they gave for 2 semi-detached houses. Big aspect to the south. And they even said to us, you can cut those trees down if you want. We don't mind losing them, because they wanted to see somebody build an example of Passivhaus at the BRE. So that's pretty crucial. This is the race course built for Gen 2 up in, Doncaster Way,
Yeah.
designed by Mark Siddle at Devereux. This block is Passivhaus. They're actually bungalows, these are them. This is a retrofit PV, they weren't on originally, that would have been because they were getting money off them. But, okay, this is fairly regimented, but they've all got private space. They've limited the road access, so that there's a lot of green space, walking space here. South facing almost. There, you can see they're all stepped up the slope, which caused them a bit of difficulty because of the junctions here. But what they did was they designed this as one envelope. So your party walls are thinner. All you've got to worry about is sound. You haven't got any heat loss to worry about because you haven't got any heat loss because it's Passivhaus. Stroud Cohousing, which is not built to Passivhaus, that's their site plan. Has anybody been there to visit it? Yeah, you've seen it. Very slopey site, designed by Archetype, who are probably the leading UK Passivhaus architects. We're probably going to work with them. But these are well orientated. They're, you know, this is the common house. These are flats here, and these are individual houses. So again, that's already laid out quite well for Passivhaus design. In terms of style, you are not restricted to cubic boxes. That's Limehouse, the Partners of Larch House, built by Justin Beer, who's again a very good Passivhaus architect. Built to sort of more social housing standards, slightly smaller windows than the other one, 12.5 metre. But then there's Crossways, which was post-construction certified, and it's bonkers, isn't it? It's lovely. You might hate it or love it, but it ain't conventional, that's for sure.
What's that on Grand Designs?
Yeah.
We did see how I did the engineering on that, which is interesting.
Did you? Yeah. Yeah, I mean, you know, architect designed house for himself, breaks a lot of the rules, form factor, but it's a Passivhaus. You know, God, that's off to him. This is something we've designed. This is where we started 3 years ago with the school buildings, and we wanted to design a classroom. And we came up with this 2-classroom unit. It's roughly square in form, but it's still single story, which is difficult with Passivhaus. We do that with a 400 I-beam, 500 wall completed, but it will achieve Passivhaus standard, even with school high occupancy, high ventilation issues, high humidity issues. This is where I want to talk a little bit about opening windows. You can open any windows you like in Passivhaus. In fact, we use passive cooling, night purging, through vents and vents to cool this building at night, if and when we get to build one. But Archetype, who've now built 4 Passivhaus schools, are using exactly the same. We did this on our own, bumped into Jonathan Hines at a conference 2 years ago and started talking, and we're just all doing the same things because it works. Yeah?
Ceiling heights are really important in that. If you're wanting to use nighttime cooling to cool the fabric of the building down, you need sort of 2.7 metre high ceilings and exposed. You don't need it, but it makes a big difference.
Can you not run the air in the foundations?
You could
Run
do,
the air
but
anywhere you like.
then you have to pump it, whereas if you use passive, you can passive ventilation, i.e. open windows.
Yeah. We can
So
combine.
this is high windows on the upside of the house, is that right? And
If
you're
you've got
using the difference
ventilation here,
you're using the difference in air
ventilation
pressure
here,
as it
yes.
cools to drive
you
it.
will get 2
temperature
things going on. You'll get a temperature differential, so you get stack effect, so warm air rises.
Yeah.
You will also always get, unless there's absolutely still air outside, you'll get a pressure difference on the building, and air will move through it naturally. So you can combine the managed ventilation in a Passivhaus with some passive ventilation techniques. You can use natural ventilation techniques to cool the building in the summer.
And
Is that
would I be right in
controlled?
thinking,
Sorry?
Sorry, I took it once. Is that controlled then? So some electronics control.
You can either have it manual, or you could have humidistats or thermostats. So if this building, let's say, hit 24 degrees during the afternoon with all the kids in it, you can have a thermostat which controls that ventilation, clicks it open at, say, 6 o'clock. Until the building drops.
Just like the conservatory,
yeah,
Yes.
Yeah.
same system.
would I be right in inferring from that because it's essentially a passive system, the costs of incorporating that are not great compared to a a ventilated system.
You've still got a ventilation system in here. You've got to have
Yeah,
one.
no,
for winter.
I mean assisted ventilation system.
Yeah, you've got to have mechanical ventilation in a passive house because you've got to deal with the winter cooling issues,
Right.
which
So
are heat loss issues.
I guess the question
But
is, what are the cost implications
Not
of
a
having a
lot.
passive system? Not a lot.
Additionally,
Not a
not a
lot.
lot.
No, it's a design issue rather than a maintenance cost.
Exactly.
But it's lower. It's lower cost to run by a long way
Yeah.
because it's opening a window as we all do.
And you're not using electricity.
Yeah.
Good. That's Debbie Dale again. Bad in terms of form factor. You add 10% to the surface area of a building, you need another 20 mil of insulation roughly. So, and that I think has got about a 25% increase in surface area. If you'd squared it off, you would have got an extra quarter floor space by the same amount of fabric just flipped over there.
But you might get a really nice terrace outside your house where you can sit in the sun, and there's always a conversation.
There are also, yes, you're dealing with sometimes external structures that are created here but can be fitted as external structures.
And the other thing is, if you take that and you repeat it 10 times in a row, then the problem becomes much less.
Yes. It's not, there's no absolutes here, you've just got to, all you do is when you design it, you bung it into PHP pins, see what the numbers say. The numbers don't lie. The numbers don't lie. So, you know, here you've got Limehouse and Larch House, both passive house, that's code 6, built to lower price. They wanted one which was a bit more expensive, bigger windows, da-di-da. Slightly different, but they both comply. A German one. I think that's horrible, but it's an early one. Here you have an external balcony, so there's no thermal bridging. Instead of cantilevering it out, you just bolt it on. So you're not breaking into your insulation. Big overhangs, that shades here, that shades here. Quite a lot of east-west glazing in that. This is the Vauban, Freiburg. If you get a chance to go to Freiburg and go to Vauban, it's fantastic. It's just urban planning really well done. But an apartment block, because you've got more here, so there's lots more floor space to external, they've been able to stick things all over the place. So you're not necessarily, if you're maybe building some of this to 3 stories, you might be quite slightly bonkers Swiss one. Box on a... I'll put that one in because that's one of British Giles's. He doesn't like Passivhaus, and he doesn't like modern design. And
That was designed, was it?
well, allegedly. So he had a go at this low energy house, and it's got chimneys and places and nice little columns. It's not bad actually. I'm being a bit mean, but it doesn't need a passive house.
It's awful.
It's horrible. Hansa House, they're building in the UK, they're kit houses. Quite Germanic at the moment, but they are adapting to the UK sort of style. But, you know, actually, you get one chance to build a house, for God's sake. If you really want to build something the same as everybody else's anyway, go for something, you know, at least interesting. But again, you can see a lot of south-facing glazing, not a huge amount here. You can see these quite deep reveals. Ran Offroad Camden, also done by Justin Beer, who did Limehouse and Larch House, very modern. That's the Essex Disability College, I forget who the architect was on that. A lot of, you know, fairly conventional building. Up in Scotland, done by, oh God, I can't remember the guy's name, he's a Hungarian architect. Built to reflect the local vernacular to some degree. Not ideal in terms of orientation, I think south is that way. Because of the roofs, quite steep roofs, but I think rather nice, rather lovely. And they're passive houses. You've probably seen that on Grand Designs. I actually haven't, but I must watch it sometime. That's Underhill, which again I think must have cost a bit. Very clever. That's one in Oregon, USA. Again, built to reflect the local vernacular. It doesn't look much different from the average American timber house with a porch, but it's actually a passive house. A friend of mine, Adam Dadby in Totnes, did a conversion. That was the original 1970s modern, lovely chimney, sort of concrete drain pipes, great, isn't it? Had a hell of a planning battle, but got there eventually with a few compromises. Wouldn't have done it, won't do it again, but that is a fully certified passive house conversion.
And that's passive rather than the What's the one for for renovations?
Enefit.
Enefit.
Enefit is a slightly reduced standard. This is Passivhaus,
That's
not
Passive.
Enefit. It was done before Passivhaus. He and Janet have written the handbook. And if you're going to do Passivhaus, buy one. Get the group to buy one. There's a lot of good stuff in there. I did his sap and coat of that. That's, I like that. You know, it's going to be cold at the weekend, I'll ask some friends round, you know, or borrow the neighbour's dog.
Oh, no. Dogs are always the wrong side of the door to the outside.
Have we got time for
A break?
I'm ready for a cup of tea.
Yes. I'm sorry, that's taken a bit longer than I expected.
Would you like to do some questions first, or would you like to do some questions over a cup of tea? Over tea. Can we have a few questions after the break then?